Now we're going to move to 2B, which is the dividend discount model. And so this particular method assumes that shareholders don't get cash from a free cash flow. Shareholders get cash from dividends. So we look at what's the future stream of dividends, and we bring all those back to present value, and that derives the price. That sounds fine, but how hard is it to derive this? Well, one of the things we see is that dividends are often seen as applicable for mature companies. So if we're doing a valuation of a startup or a high growth company, you cannot use this dividend discount model. Let's start with getting at some math here. So let's start with a zero growth rate. If D1 equals D2 equals D3, etc., the price equals the present value of that stream, which is simplified to right here. If we have zero growth, you simply take dividends divided by the required return for the stock. So that's very simple. But no growth is not very exciting. So what happens if we have growth? Well, the next one is to make an assumption going the other way, is that we assume that we have constant growth and it goes forever. And I know that's a long time, right? So D1 equals last year, D0 times 1 plus G. D2 equals D1 times 1 plus G. And we do this forever, and we get to a generalized formula where D for time t equals D for time 0 times 1 plus G to the t power. And we can derive that for any amount of time, t1 to t2, etc. So we have this, instead of a flat line, we have this growth. And it's logarithmic because it compounds. It's similar to what we've seen when we're looking at the risk and return relationship and the percentage growth in a stock. So we have this handy formula, which we have used already, but now we're using for dividends. Dividend times 0 times 1 plus G divided by R minus G is the value, which is similar to what we use for horizon value. Another way to look at it is dividend of time 1 divided by RS minus G is the price at time 0. Those are two ways to derive the same idea, because T1 is equal to T0 growing in 1 year. So that is the DDM with a constant growth rate. So let's try it out. So a company has a beta, company A has a beta of 1.2, risk-free rate of 7, market risk premium 5%. What is the required return on equity? That's CAPM. Should sound pretty familiar. So let's do that. Required return on equity equals. It is the risk-free rate, which is 0.07, plus beta 1.2 times market risk premium 0.05. And that's 13%. All right, let's express that as a percent. And that's the first piece. So for note taking, I just have it right here, which is here for future reference when you look back at these notes. All right, so that's the first one, easy one. That's just CAPM. Second one is we use a DDM with no growth. So this is that first assumption, and $2 dividend. So what is the value of A? So let's go to the second one. And we could see that dividend discount model value equals the dividend of 2 divided by 0.13. So it's $15.4. And again, it's here for easier reference in the future. All right, so that's number 2. We got DDM using zero growth.